Good morning, everyone. Sorry for the slight delay there kicking off. Welcome to this nearForm webinar. We have nearFormers and some Microsoft people here as well. You today. Let me just get started here. Just tell you a little bit about who you're going to be hearing today. First of all, there's myself, Conor Neal. I run product here at nearForm. I'm based in West Cork in Ireland. We have Alex Nall, who's one of our senior DevOps engineers, who will be coming to you live from outside Barcelona. And for this morning's session, we'll also have Asim Hussain, who's a senior cloud developer advocate with Microsoft in the UK. This evening's session, we'll have Brian Holt. Just to give you a quick summary of what we're going to be talking about, I'll give you an introduction to nearForm. I'll tell you a little bit about our Node.js images, but the bulk of today's session will really be a demo by Alex, showing you some interesting things that can be done running Node.js apps on Azure and some of the integrations you can do and some of the nice AKS features that are available to you. We'll follow that then with a Q&A session between yourselves and ourselves and Asim. Just to say, there's a Q&A feature in Zoom, so any questions you have, please use the Q&A feature rather than the chat feature, and do so from now on. So feel free to put in those questions, and we'll mostly get to them during the Q&A session. If there's anything immediate, some of the guys who are on, Sean, who's facilitating today, and Barry may be able to actually answer as we go along. But as I said, the vast majority will be at the end. So just to tell you a little bit about nearForm, if you're not familiar with us and what we're about. We've been around a few years, 2011. We're now over 130 people and we're really spread across the world. So while we're headquartered in Ireland, we have very much a remote model. We want the absolute best people with the best skill sets working from wherever they want to work. As I said, Alex there is outside Barcelona. I'm in semi-rural Ireland, and we have really nailed and mastered this idea of remote working and remote teams working together. We have over 150 production systems shipped, all of them full stack JavaScript, the vast majority Node.js based, and most recently React and Node.js based, but not exclusively. And we've been doing some interesting things. If you check out our blog, we've been doing some interesting things in some other spaces around data science and so on most recently. We're very, very heavily involved in Node.js, the project, not just as a user of it like many people are, one of the fastest growing open source projects out there. But we're deeply involved in the actual core project itself. We're involved in many of the parts of the Node Foundation. We have 7 nearFormers who are Node.js core maintainers. I'll have a few more stats about that in a minute, but it's to give you a sense of our commitment and our kind of expertise around the whole area of Node itself. Now, having said that, a lot of people think that's what nearForm does. nearForm is a Node.js house, but actually what we're really about is developing very complex solutions for enterprise customers around the world that happen to use Node, that happen to be full stack JavaScript. We have in recent years taken a very strong design-led software development approach, and that has been delivering success time and again for us. Again, I'd guide you over to our blog to read more about our design-led thinking there. We have some really interesting stuff happening. If you're interested in the concept of design-led open source, which we believe is quite unusual, go check that out. But we have these teams that build full solutions for customers. That's a huge part of what the company does. And then on top of that, we have things like consulting around Node, around JavaScript, around agile and getting people to where they want to be in terms of internal delivery. As you'll see today, our DevOps and our DevSecOps expertise is second to none. We really have a world-class team of DevOps people now delivering these secure solutions for people, mostly in the cloud context, but not entirely. And we very strongly take part in many digital transformation projects, really on the delivery side of that, and enabling people to, as I said, to get to where they want to be. And then most recently, as I'm going to talk about in a second, we have created our own Node.js distribution with associated commercial support. Here's just a quick list of some of the reference clients we have. They're, they're global brands. They're people you will know. They're people you have heard of that we have provided, huge amounts of assistance to, both in terms of solution development and consulting. I'm not going to spend long on this. This really is trying to snapshot what we do in terms of that solution delivery. It gives you a sense of, that agile approach we take, that iterative approach we take. As I said, the design-led approach, using design sprints to drive everything from, as I said, commercial projects to open source projects. nearForm hearts open source, absolutely we do, not just Node.js, JavaScript in general, all things like React, but not just not just focused on React. We can all get a little bit hung up on React as the only front end framework. There's more to front end than React, but we're really deeply involved. We punch way above our weight in terms of the amount of resources and investment we put in to the open source world. We really want to be givers, not takers, when it comes to open source. I mentioned Node.js and our contributions there. As you can see, more and more, I mean, it's pretty shocking that a company of our size was responsible in 2017 for 9% of the commits to Node.js core. We reviewed 66% of those commits. And in 2018, we've actually blasted through those numbers already. We've added we've hired another Node.js core committer, and we're sponsoring yet another person who's heavily involved in and very active on the Node project. But it's not just about Node, as I said. Node is important, but we do far more than that. This is a sample, really, of some of the open source projects we either started from scratch ourselves, nearFormers as individuals started, or were heavily involved in. And just to kind of touch on some of them, Pinot is absolutely the fastest logger out there in terms of Node.js. We have more and more customers just moving to it simply because it's absolutely the best there. Node Clinic and the associated 0x project are very much about figuring out your Node.js performance issues. So this is something we have been putting a huge amount of effort into in recent months. Do try out Node Clinic. You'll learn an awful lot about the behavior of your Node applications. We're building even more complex tools there, very heavily involved around the data science side of things. You have things like Fastify, the world's fastest web framework. If you're into speed, go check out Fastify. Udaru is something, again, another one we've been building on. It's a policy-based authorization module, and you hear lots about authentication. You hear less about authorization in a Node context, and this gives you a framework and a structure for doing that. We also sponsored the Chew front-end framework. As I said, there has to be alternatives in everything out there. Chew is a very lightweight approach to doing front-end development and is seeing lots of traction in recent months, and we're very pleased to be able to sponsor that. And then all the way to IoT applications, something like Mosca is it is absolutely the MQTT broker that everyone uses, and that was built by nearForm. So we talked about the fact that we launched Node.js distribution recently, and what is that and why would you use it? So first of all, it's fully OSS. So this isn't open core and closed source additions to it. It is the Node Foundation source. Really what we're doing is just providing a service to the community out there by building containerized images for a suite of different operating systems and having those available almost immediately after the Node Foundation does a release of Node. So whether there's a Node Foundation release or there's base OS image updates, we generate our releases, as I said, almost immediately after that. Our commercial support is then associated with that, but you can go and use these images now. These are freely available images for Alpine, for CentOS, and for RHEL. So just go to our presence in Docker Hub and you can make use of them. If you want commercial support, we build the commercial support mostly around the currently the 8.x LTS release. We have the other versions available. We'll have 10.x available for people to use as soon as it's available later in April. But really the focus is on LTS and enabling you to roll that out in your containerized environments wherever you need it. We really are, it's no exaggeration to say we're a global center of excellence for Node.js. You saw how many Node Core contributors we have. So we have a full support process. If you have a suspected Node Core issue, we can triage it, we can get those PRs done, we can get PRs submitted, and we can generate those releases that you need. We have standard and premium support with associated SLAs, and we have very transparent pricing based on the size of your Node.js deployment. But that's enough from me. I think the bit you'll all be very interested to see here is, there is some Node.js images. They're useful and they're valuable. Now, how could you use something like that in the context of Azure? And with that, I will hand over to Alex.
Yes.
Perfect.
So thanks, Connor, for that. Yes, I will be doing the demo for today. And I'll be using many of the things that Connor has been talking about, our node image, a few of the projects that we saw come by in the slides. And I have a message here. Can I maximize my screen? Yes, that is a good one. And probably make it a little bigger. So, the demo is going to involve an application that is built on this Node.js image that we're distributing and maintaining. It's a simple API that is able to return for a given city the amount of kilowatts of solar power that can be generated in that location. So the entry point is the API. It takes the city name, geocodes it into a latitude, longitude with an external service somewhere on the web, then takes the latitude and the longitude and passes it on to the solar service, which in turn queries an external service that will return the average amount of solar power that's generated at that location. When we've asked this information from the external service, once we'll store it into the database because it's not very likely to change. So we'll just serve all the next requests for these exact same coordinates from the database. And in the API, when the number of watts gets returned, we cache the result for about, I think 10 seconds is the caching set for. This gives us a nice micro architecture that generates some logging and some traffic and also some interesting things to look at inside the Azure infrastructure. So what does this app look like? I have it currently deployed. So probably make this a little bit bigger as well. I have asked for solar power of the city of Redmond. Let's ask for another one, Tremor, the headquarters of nearForm. So a few things we can see in the output to help us determine what's going on behind the scenes. One thing here is this request was not cached. I didn't ask it less than 10 seconds ago. And then we have here some information about the solar power. So the annual generated kilowatts for Tremor based on a 4 kilowatt system would be 5,392 watts, more or less. So if I refresh this, we can see that the data is now being served from the Postgres database. So local true, something that signifies that we served it from the database, but cached is still false, which I can make true if I request this a bit quicker. So now we're serving the request from the Redis cache. So we're not even hitting this second layer of our microservice architecture. So that's the basic functionality of what we have. This thing right now is running on top of Azure infrastructure inside AKS, hosted Kubernetes. Just came out inside the Azure infrastructure. Now, I want to walk you through how you deploy these things to AKS. It would be easy to do these things from my local laptop and just create the Docker images and all those things. But we're talking about something that should, the way you want to run this in production. So we're going to run this through a build pipeline. And basically, if I make a commit, so let me go back to the output. Right here, you see the reason, which is just a property from the JSON, is Solar Demo. So if we change that to something else, let's say a webinar about Azure AKS and Node.js. Here we go. And then I use my Visual Studio Code when it wakes up to commit this and send this to my Git repository. Better reason. And then what I'll do is I'll as this thing runs through the build pipeline, I'll walk you through what happens in each step. So as a Git host, Git repository, I'm using the Visual Studio Team Services. It's something that kind of encapsulates something like a GitHub or any other Git repository hoster, but it also includes build and release pipeline. So if I go to the overview of the builds, we should be seeing a build running because I just did a commit. That's a bit slow because I'm streaming video as well. So hopefully this will come up momentarily. Okay. And let me refresh that page. Maybe I stop streaming my video. Yeah, here we go. Okay, so we can see there's a build in progress at the moment. The commit, better reason, is the one I just sent to the repository. And if we zoom into that build, we can see here on the left all the steps that were defined in the build pipeline. The first two are standard things that you might see in something like Circle CI or Team City. You need to get an agent to actually run this build for you. We need to initialize the job. Let me just keep it in the overview. And then we need to get sources. As soon as the sources are there, the actual build pipeline, the part that I defined, will start. We're doing an npm install. Let me just zoom in on that. So when you commit a Node.js to a Node.js project, you typically do not commit the Node modules. You want to build those on the target platform. And in this case, you want to make sure that the place where I'm running the test, the agent, is also the place where I'm building or pulling in the dependencies. Next step is test, npm test. Let me just make a small sidestep to the application. So npm test is part of the part of the package.json. So it's a definition of, well, in this case, the scripts that you want to run. So there's a test which uses the tab framework. There are other scripts, we'll be seeing those later on, to start the API. So that's the initial entry point, and to start the Solar service. And then there's also something to migrate a database. So let's say there's changes in the database setup, as in adding columns or changing things. Then we can run a migrate script right before we deploy. Now, while we're here, it's maybe good to have a look at what this application is using. So, as I said, I'm using some of the things that Connor talked about. The Fastify framework, there's the Pinot logger, PostGrader, something we got involved in quite recently, which is actually the package that runs the migrations, and then some various bits to connect Fastify to Redis. Oh, I didn't mention Redis yet. And Postgres to Fastify. Application insights. This is something I'll be talking about a little bit later on, but it basically, well, does what it says. It gives you insight in your application, and in this case, the Node.js application. I believe there are, you can run it for some other languages as well, not just Node.js. So if we then go back to the build pipeline. So after we run the test script, there is another step which builds the image. So typically what you want to do is after unit tests are run, you want to build an image, and that image is what is from then on frozen and travels through the system as is. So if you want to run integration tests or something that actually hits the API with maybe Selenium or something similar, then that is the image that ultimately would be the one that would be deployed to production. So inside the building, we're just targeting the Docker file from the repository. So I think this is the path. So under infrastructure, Docker, there's a Docker file, which I have right here. And that Docker file is super simple. We're starting out from the nearForm Alpine Node.js image. I'm using version 9. I like to live on the edge a little bit. If you specify 9 without any further versioning, so 9.11.1 or something, you will always get the latest 9. So what we do when there's a new version of Node being published, being released by the Node Foundation, we'll build that new version, and then we'll tag the latest major version with the latest version that was released. So if you keep it like this, you will always be on the most recent, most secure version of Node. And the same goes, obviously, for version 8. Just kind of walking through this, you know, we're copying package.json and then running the npm install, which is what you see right here. So there's lots of output from npm install. And in the end, we have success from the building of the image. Next step is pushing the image. So we're pushing the image to a Docker registry that only we have access to, because now the image has proprietary code, something that, you know, our enterprise has made and spent a lot of money on, and we do not want to publish that on Docker Hub for everybody to download. So we're targeting the registry that was provisioned specifically for this project. I will get back to how I do that a little bit further in the demo. So let's keep going on the actual deployment. But this registry is provisioned inside the resource group where the entire application stack and all the adjoining services are located. Next thing in the pipeline, we're downloading kubectl. because AKS is Kubernetes, and we want to be able to operate this cluster from the build pipeline. This is not a built-in thing, but it's something like an add-on you can add to the build system from the marketplace. And there are, well, hundreds, if not thousands, of add-ons that you can add to your build pipeline for lots of different purposes. So one of the things I have to do is delete the migration job that was created by a previous deployment. It's just the way jobs are working in combination with Helm. Mentioning Helm, which is what happens in the next step. Helm is a way to encapsulate your Kubernetes manifest definition in a way that it makes it really easy to manage. So you can specify parameters, and that way you could like spin up this application stack for, say, staging, and you can do the same thing with just changing a few parameters and spinning it up for UAT or production. You could change something like the number of replicas that you want in a specific environment. I'll show you what these Helm files look like a little bit further into the demo. And when this is done, the deploy has taken place. And if I now go to ask for a new city, or I can ask for the same city, let's say Amsterdam. Here we go. So now we have a newly deployed version because the reason is now webinar about Azure AKS and Node.js. So that's how things get deployed. There are many more things inside team services you can leverage to make this more robust and even more flexible. But this is a way to do this. Now, I mentioned the infrastructure this is running on. So inside the repository, we also have everything we need to provision AKS, obviously, but also all the other parts we need to run this application. So if I go back to the initial picture, we'll need infrastructure to run it on, AKS. We'll need a Postgres database. We'll need Redis. And we also want to keep an eye on what's going on. So we want to know about all the logs from the containers. We want to know about what's going on with the actual Kubernetes cluster. So, what is the API server doing? What are the events that are coming by? I mentioned it quickly before, the application insights is also something we need to provision to enable us to kind of look inside the application. So inside the API and the Solar service to see what's going on there. For that, I'm using Azure Resource Management templates. A lot of text here. These are JSON files that specify pretty much every part of your infrastructure inside Azure. If you're familiar with AWS CloudFormation, then this does not look all that strange. I'm not going to go through each and every one of them. There are parameters to specify things specific for a certain environment. So I could spin this this infrastructure up for, let's say, a staging testing cluster. I can do the same thing and change a few parameters and make it a production cluster. Let's say I add more agents, like you see here, the variable agent count. I can have a small cluster for testing and staging, and I can have a really big one for production. So that's the AKS cluster. Then there's workspace to load the analytics and logs into. So that's like a workspace, which we'll be putting some other stuff into, like the solution you'll see down here. So this is a solution for OMS, operational management, that understands Docker and understands Kubernetes. So it's something that just with adding a few lines in your template, you can spin up. So it makes it really easy to get insight into the mechanics of your cluster and your containers. Then there's a application insights component. So this is like the framework that understands input from application insights, and this can come from various different languages or library implementations, I would say. Then we have a few linked items. So there's the Postgres. Where do we have it? Here we go. The Postgres server, and we have the Redis cache. And this is the registry I mentioned before. So there's a registry inside this template that gets provisioned in the resource group. And here we are adding the connector for the insights framework for Node.js, as mentioned right here. Just, you know, like the adapter that understands Node.js inside the framework and translates it to like a generic format that then gets output on the various graphs and schematics. Something here at the bottom, super important, Key Vault. All of our secrets are stored inside the Key Vault, which is something similar to HashiCorp Vault, if you're familiar with that. Maybe interesting to mention that we are also provisioning a user that is able to access the Key Vault and add, remove, change, or basically has the rights to manage the Key Vault. And there's an extra role, which is the service principal object ID, that is used to spin up the AKS cluster. I will get back to that when we go through the Helm charts, but this is needed so that things inside the AKS cluster are able to access the Key Vault to obtain secrets. Now, what does this look like when you run it? First of all, you should get some coffee because it takes about 15 to 20 minutes for the entire thing to run. I'm not going to make you sit through that. I've already done that, obviously. And what comes out is something like this. I forgot to mention that to make this easy, what Azure does, it provides you with templates to run these resource templates and parameters in a really easy way. So this is a shell script. You know, it's also a couple of hundred lines long, but what it does, it kind of gathers. I've taken the basic one and then you know, kind of iterated on it so it would fit with what I need. But what it does, you can either specify all the parameters that are required, the secret things that you do not want to put in any files, and if you don't specify them, it'll ask you for them, and then run the actual deployment of the template. So the template file is contained in this variable, and then there are a bunch of parameters, things that we do not have defaults for, or we just generally do not want to touch any disk, really. And when that runs, and after it's ready, we'll fill the Key Vault with some of these secrets that we talked about before. So we need an application insights key. We need a Redis secret. We need to know where the workspace is that we're going to send these application insights. There's a Postgres password. So all of these things also are added at the end of the deploy script, so that whenever it has run and you enter the vault, you can see that it's already containing all the secrets that we need for the stack. So there's an insights key, and the workspace ID, there's a workspace key, and the Postgres password for the application. So this is not a super user password. That doesn't even get close to operational software. That only happens at the moment you provision it. And then there's a Redis secret. Now, if I go back to the overview, for those of you familiar with AKS, the container service that can also do Kubernetes, but also does other schedulers, this looks a lot cleaner, at least for me, because when you spin up an AKS cluster in a resource group, you have all the nodes, the nodes of the cluster. You have a master, you have network, you have security groups, a whole bunch of things. Here all you see is AKS, and if you go into it, you really can see the number of nodes. We have a one node cluster in this case, and that's really it. There are also not very many options here. You can still get to those VMs and those network policies if you go to the overview of your resource groups. What AKS does, it spins up a new resource group that houses all these things and kind of abstracts them away. You could put this behind a different role, so developer roles can't even see that, for instance. And here you see kind of the same resources that you saw at AKS, with one major difference, is that there's no master. The master is managed and controlled by Azure, and as far as I know, you don't really have any access to it. But still, you can get to agents, the Kubernetes nodes, as they're also known, and you can pretty much operate many of the things apart from the master. So let's go back to our resource group for this application stack. We have Postgres, Redis. There's not super a lot to tell about these two services because they're fully managed and they don't really require a lot of setting up or configuration. The only thing you have to look at is connection security. If you, for instance, want to access this from another place, you can add IP. So this is like firewall. And we enforce SSL, which is also the default. To be able to access it from inside other Azure services, you need to flick this one on, which is also part of the deployment. And kind of the same goes for Redis, which is maybe even more limited in some ways. So that didn't really, oh yeah, here we go. So this key is something that we've already extracted during the deployment process and added to the vault. So there's, if you set up your templates, your ARM templates well, and also do some introspection after things have provisioned, then it becomes really a repeatable solution. You can check the whole thing into version control, and it becomes really really well manageable. Now, the next thing I want to dive into a little bit is the Helm charts, because I've kind of skimmed over how we, what this looks like. So I have the Kubernetes dashboard here. So there is a, the application stack is made up of a few deployments. There's the OMS agent, which is something that is a pod inside the cluster that has access to the OMS workspace, so it needs the workspace key and ID, something from the vault, and sends all these container logs and all these events from Kubernetes to the workspace. I'll show you that in a minute. Then we have deployments for API and Solar with their respective replicas. And then there's a job for the migration, which ran and is now idle. So it's not doing anything. It checked and ran the migrations. And below that, you see the actual pods that are resulting from these higher level resources. So if we then look into what these Helm templates look like, because there's a bit of a trick to getting the secrets from the vault into the application stack. If I, for instance, take the OMS agent, this is a Helm chart that is basically Kubernetes manifest with variables. So something like this is used by Helm to kind of interpolate different strings, in this case template, full name, and there's some other built-in variables that you can use. And I've specified my own variables. So one of the things I specify is where is my registry, the registry that we provisioned earlier, the name of the deployment, also part of the provisioning, and then a bunch of other stuff. What is an interesting detail here, the image that we're building during the build process gets a tag in the build pipeline. And I'm putting a fixed number in here. So how do I make sure that when I build, I then deploy the latest version? What happens in the build pipeline to get Helm to tag, to use the latest version that was tagged during the build? You are able to specify image tag with a variable from this specific build. So build ID is the number that this that the current build was tagged with. So that's what we basically overwrite this number here with. Just stepping through a little bit more, there's API, the API service, some configuration for Solar. So Solar connects to the database and API connects to Redis, like in the initial picture. Then we are configuring Postgres, and then there's an Nginx image somewhere in there, and we configure ingress. So this is something specific for Kubernetes. You can spin up an ingress controller, which listens to an ingress resource. And in this case, it tells it to use this domain name to listen on, basically, and send requests into the cluster. So I was about to talk you through how you get secrets. So the OMS agent is something that sits in the cluster, has access to the Docker daemon on each node. So that's why it is a daemon. It runs on each node inside the cluster. And it needs to have access to the workspace ID in the workspace key. So I'm just taking this as an example. It works the same in API for Redis and in Solar for Postgres. So what we do is we do an init container. An init container is something that runs inside a pod. A pod in Kubernetes can consist of more than one container. Init containers run before anything else. So the init container takes the service principal that is present on each of the nodes. So this happens during provisioning, and uses that service principal to gain access to the vault. And this is the part in the template right here. So here we give access for the service principal to get secrets from the vault. So what the service then does, it gets a configuration of what it needs to get from the vault, and then writes that into /vault for that container. Now, we do not ever want to have these things touch a disk, right? That's what I said. So what we do is we are using /vault as an in-memory file system. So this thing never hits a disk, it just stays in memory. And inside our actual container that spins up after this thing has run, we get, we also connect to the same vault volume right before we spin up the application that sends all this data to the OMS. We just copy the workspace ID and workspace key from this vault location to wherever the application expects it. And in this way, you know, if you need something like an environment variable or something else, you can do it in a similar way. You have access to it. It's something that is shared on a shared volume, and it never actually touches a disk. How am I on time? Pretty good, I think. This is how secrets get passed into applications in the cluster. And if I then go back to, for instance, our API. So the API is sending application insights data to the OMS workspace, and it uses the Azure Insights key, which is provided to it in a similar way that I've shown before for the OMS agent. And the same thing goes for the Redis password. There's an init container, and it provides it in this way that runs it right before the process starts. So this is all fine and well. Now we have all this infrastructure. We have it all connected up. We have secrets to access things. Now let's see what it looks like. I'll just walk you through some of these things that give you insight into your Node application running inside AKS. So I've provisioned it with ARM templates. If you're not comfortable with that and just want to play around, you can do all this through the web console. It's just a few clicks, really. And there's, I have to say, there's excellent documentation as well to get yourself up and running if you do not want to use the templates. So this is the container solution. So the thing that understands Docker and it understands Kubernetes. And really, if you are familiar with other monitoring or logging solutions that are often used in Kubernetes, Docker areas, then this, really looks very familiar. You have your container logs. There's Kubernetes events. So all of the events that are being sent around inside the Kubernetes management layer, so to say. We have nodes. We have here some metrics about the cluster. So we have process count, CPU usage, and then there's some, so even some hints about what things you could ask for instance. And behind this, if I just zoom into here we go. Well, maybe I should not. Well, so if you just zoom into one of these things, it opens up basically log analytics. And log analytics is similar to Elasticsearch, Kibana, something I've used before. I'd say this is as elaborate, if not more. And it just gives you a very explicit query language. Oops. To query all the logs from your containers and also your nodes, etc. So here we have an incoming request, remote address. So this is something that was generated from the Solar service. And it's also real easy to customize this stuff. So you can search for a bit more generic things. So let's say I wanted to search for anything or in any container that is named Solar. I just do Shift Enter, and then I get all the containers, not just the one. So here you can see I have we have 5 replicas of the Solar container, and they're here on the left, so you can see all the containers and then even zoom in onto a specific one. You can probably PhD on just this one screen. It's just a very vast source of information if you're looking for a problem or trying to analyze a situation. Getting back to the main screen. So we've kind of seen log analytics. So this is kind of like a direct route to the same thing. And the next thing I wanted to show you is the application insights, which is really looking into the node processes that are running inside the cluster. If you're familiar with something like App Dynamics or New Relic, then this is kind of what you can expect here. So in the overview screen, you see like the default dashboard. Down here is like AppDex score. So what's the percentage of requests that made it in less than 250 milliseconds, and then some other timings below there. What is always interesting to look at is the application map. So it has a concept of what's going on in the cluster and what things are talking to inside the cluster. We have HTTP calls. Let me make the time range for the last 30 minutes. Here we go. So we haven't been doing a lot, I see. So there are calls to API geonames.org, and then there are calls to the webinar Solar service. And like anything you've seen, you can click on things to zoom in, which then gives me more detail about what's going on. In this case, there are calls, dependency calls, going to an external service. So this is a call from API to Solar service. And it just gives me a bit more detail about what the call was for, what the result code was. And then if I want to, let's say there's a problem here, if I wanted to like get more info of what happened before and after, there's, another way, another place to click on to zoom in even more. And it gives you this really nice overview of events that happened in the vicinity of this specific target. So there was a get search JSON, which is a call to the geocoder service. And then there was a health check, something that Kubernetes does to make sure that your pods and your containers are alive. And there was another call. So, this just gives you very quick, very to the point insight in your application. Oh, I went a little bit too far. Did that work? So I just wanted to, as a last thing, just quickly go through some of the things that you see here on the left. So this, this is an overview of some of the views that you see here on the left. What I haven't done is made a user interface, but you are able to add user tracking and funnels and even integrate that into what you see here in the application insights. So you can see which user request triggered what backend request, and also round trip times, etc. Performance is one of the more interesting things if you're looking at high traffic situations. Again, a very sensible, easy to understand screen where you can see the number of requests on a timeline. And then here there's a list of requests with their respective times. So as you can see, I've been testing a bit already. And also again here, you can click through and get more information about the request or the event. And if I zoom into the last 30 minutes a little bit, I asked for Amsterdam, which then resulted in a call to Solar service with these coordinates. And if I click on that, it doesn't give me really all that much. But what is interesting is the dependencies. For API, the Solar service is a dependency, so that got flagged as a dependency. And then there's the geo coding for the city Amsterdam that took place. And we can zoom into that by just clicking through the actual event. Here we go. So right here, we see the actual call that was done through to the GeoNames API to get the coordinates for Amsterdam. Wealth of information to track down bugs or problems or performance issues. Everything is also integrated with the team services. So from an issue that you find here, you can immediately create a work item so that it gets tracked into the team services system as well. And I think that's as far as I go for the demo. So let's hear it for some questions.